This is an amateur rocket called Inceptor, which I designed with a friend to fly to 200 meters. In this project, almost all parts had to be made by us, since rocket parts are not readily available in Greece. This includes the rocket motor, for which we chose a fuel mixture of sorbitol and potassium nitrate due to its ease of manufacture. The fuel was melted, mixed together, and then poured into the motor casing. A mandrel was used to create the combustion chamber. Initially, a copper tube was used for the casing, but we later switched to aluminum for weight savings. I was responsible for designing a stand that would be used to measure the force of the engine so that we could use it for simulations. I designed the stand structure using Fusion 360, and then all the wood pieces were cut and assembled together. Since I was going to be testing a relatively low power motor, I didn't use any heavy duty materials and instead opted for wood. The test stand uses an Arduino Uno and a load cell to measure the force produced very accurately. Combined with a low voltage battery, a relay, and an electronic match, the test stand is able to initiate all tests autonomously. After the tests were conducted, the resulting thrust curves could be imported into OpenRocket. This allowed us to evaluate different rocket and motor designs to see if we could reach our 200-meter goal. Another part that I was responsible for was designing and manufacturing the flight computer that we would use for the flight. I designed a 2-layer PCB using Eagle, opting to use mainly through-hole solder components for ease of manufacture. The notable exception to this rule was the flash chip and SD card sockets, which needed to be soldered on to prevent data loss. The flight computer uses an initial measurement unit and a barometer to accurately measure altitude, position, and acceleration during the flight. This data is then logged onto the built-in flash chip and then copied over to the SD card to be evaluated after the flight. The other primary purpose of the flight computer is to eject the parachute at apogee. This is done through 2 separate channels, which use MOSFETs to route battery power to a pyrotechnic charge inside the rocket. To test the system before launch, a pop test was done.
Yes! Alright!
After all the final systems were tested, simulations were done, and the final rocket was assembled, it was time for the launch.